Okay, so to do number 43, there are a whole mess of formulas here. And earlier I was asking what the hell. So here are the formulas they give me. H of x is f of x times g of x, capital letters all the way through. Little h of x is f of x times capital G of x plus capital F of x times little g of x.
Yeah, why don't you just pick a different variable?
J of x, I don't know, or variable choice, is little f of x, capital G of x, minus capital F of x, little g of x. Oh, I know why they did that. That's so. Over g of x, sorry, capital G of x squared. My marker is dying because I've written too much. Okay. And then they tell me that f of x, capital F of x is x cubed, cubed. Little f of x is 3x squared. And h of x is 3x squared sine of x plus x cubed cosine of x. And I'm supposed to find h, capital H.
Just that's good.
Yeah, just capital H. Okay, hang on, wait. So, it should be noted that the reason they're doing capital letters and lowercase letters is that they think that in calculus you will have a way to move from capital letter functions to lowercase functions. We can see one of those rules right now.
Oh, yeah.
From x cubed, right? They got 3x squared. So please note they took the 3 down and they did the thing to the 1 lower power. You guys see that? So they took this 3 to get from capital F to little f. They took the 3 that was in the power down.
Is that like an actual rule?
Yep.
Oh.
Yeah, this is a derivative. So this is how you differentiate the cubic function. You get this. So, for your guys' edification, this little h here is a thing called the product rule, which tells you how to differentiate derivatives, or differentiate products. This thing is a thing called the quotient rule. I spelled the quotient wrong. I feel like I spelled it wrong.
No.
Alternative fact, it's spelled wrong. So, what?
Just 8.
Okay. Anyway, so product rule, quotient rule, these are things you will know and love. They're not usually phrased in quite this way, but this is an equally valid phrasing. So, what do I need to do? I need to find h, right?
Yeah.
So here's h. It's capital F times capital G. So, first things first. It's supposed to be capital F times capital G, right? What do I know right now?
We have no capital.
I know capital F is x cubed.
Yeah.
Now I need to go out and find
Capital G.
capital G, right? So I'm missing this. Once I have found that, I will be done. So this problem of find h boils down into the sub-problem of find g, capital G. Okay? How do I find capital G?
Look at that. You could probably solve h of x for it.
Oh, okay.
Yeah.
So I know that I've got this product rule thing, which is h of x, and there's also this thing here. You guys see that? So I might think to myself, okay, so h of x on the one hand is f, little f, times capital G plus capital F times little g. And on the other hand, they told me this is 3x squared sine x plus x cubed cosine x. So can I match chunks? What do I know here?
Little f of
Little
x.
f and big F.
Okay, so this piece is little f, right? That 3x squared there, that's little f.
Oh,
This thing is, x cubed is
f of x, big f of x.
capital F. So those are looking like they're kind of checking into place, right?
Yeah.
So what would your supposition be?
Big or capital G of x is sine of x.
Okay, so this is g of x, capital G of x is probably sine of x, and little g is probably cosine of x. Do I know for a fact that's the case?
No,
Probably not.
but yeah.
It's certainly like nudging and winking at me at least. You guys see that? Do I have any other information I can use here?
I don't know if the quotient rule is there for.
Yeah, so the quotient rule is probably for number 44,
Okay.
right? So I might go check. Oh yeah, number 44 has a J in it. Okay, so I probably don't need this. Yeah, so I think I'm going to go with these guesses.
Wait, didn't you? Yeah, you already found G of x. Then if you assume it's sine of x.
Yeah, so if I assume it's sine of x from kind of pattern matching here,
Yeah.
then I know g of x is sine x, and then I take that, plug it back in here, and so I find out that h of x is x cubed times sine x.
So for all of that
Cool.
stuff, something as super, simple as pattern matching.
Yeah, and so what they've said here, so ultimately the thing they said here is if you differentiate this function, you will get that one. Derivatives are a thing about slopes of tangent lines, right? You guys remember me at least saying that?
Yeah.
So the rule for finding slopes of tangent lines of this thing is that thing. Huh, weird. Cool. Questions, thanks? There's also one more thing here, which is that apparently the slopes of the tangent lines for sine are given by cosine. Why would that make any sense?
Cosine is sine shifted over.
Yeah, so if I've got a sine curve, right? It looks like this. So what happens to the slopes of the tangent lines? Well, like they're flat here, right? So my function for slopes is 0 there. Over here, it's pointed down, right?
Right.
You see that?
Yeah.
Negative something. Turns out -1 is a really good guess for that, but we'll talk about why later. Right here, I'm back up to 0, right? And those shifts are kind of gradual in between, yeah? So it maybe shouldn't come as a huge surprise that you get something that looks like,
Cosine.
yeah, at least a sine curve shifted around, and cosine's a good choice. Cool. That's not by any means a proof that that's true. That's just a like, oh, look, maybe
Huh.
this would make sense. Questions, things? Okay.